There's the Git Bash icon. And hopefully you guys got my email today about making sure you had your GitHub account set up, and that if you have a PC, you will need to download and install the bash shell or Git Bash here. And you might get this colorful icon like I have. Your icon might be all orange depending on which version, which operating system you're using, etc. But if you had a Mac, all you really need today, instead of Git Bash, you need to be able to access your terminal window. So if you go into that email I had sent today, there was a brief link to about a minute-long video that shows you how to go ahead and access that window here. Yeah, right, flexing my metal on you. Yeah, I got to change my background here. It's old, very old. Now, we're going to run Git Bash in just a moment. Before we do that, I want to direct your attention to a few items that are on Blackboard here. So let me pull this up as well. Make sure I have the right screen share. Yes, okay. So on Blackboard, okay, if you click on the Supplemental Materials tab, like right over here, share it. Yeah, there we go. Okay, if I was to click on the Supplemental Materials tab, okay, that brings you here. And I've added this link to a Google document which has some useful commands for the CLI, the command line interface. Some of those are applicable with Git. Others are just general commands for the command line interface to be aware of. So if you were to click on that, it takes you to this file here, and I can see a bunch of you guys are looking at it right now, which is wonderful. I can see you all up there as your anonymous panda versions of yourself. And what we want to do today is essentially utilize some of these commands with Git in a way where we can manipulate data that's in the cloud. So we can pull data from the cloud from our GitHub repository. We can manipulate it on our machine. And if we want to, we can update those files and we can push that information back up so that the data stored in our cloud repository is the most recent version of those files, is the updated or reflects the updated changes to those files. So there are a lot of useful commands for the CLI that I'm going to show you in just a moment. In fact, if I shrink this down, let's go ahead and open up Git Bash. Okay, when you open up Git Bash, you should just see pretty much a blank console window or a blank terminal window when you do this. And this is the window where we're going to be writing command lines. Now, right now, Git itself is pointed to a very particular folder on my computer, to a what we call a directory on my computer. This is in my C drive, in my user folder, in the Steve user subfolder. Okay, but that is not where I really want to be to do my work today. So what I'm going to suggest for the moment, and you may or may not need to do this, it is possible that you're already pointed to your desktop, but I'm going to use the change directory command, which is just CD and then a space, and I'm going to move into my desktop folder. So I'm going to say CD space, I'm going to change directory to my desktop, and when I hit enter, you'll notice now I've moved into my desktop folder. It says, oh, we're not in Steve's folder anymore. We're in specifically the user Steve's desktop folder. Okay, and my desktop is crazy messy. In fact, I'm going to show you guys how messy it is. Please do not judge me. Okay, but let me show you all the junk that is stored on my desktop. I mentioned I have a dual monitor setup here. So I'm going to show you my other desktop just so you can see a bunch of crap that's on there. I got a bunch of junk on here, a lot of files that I got to clean up. There's a lot of folders too where I'm storing books, documents, etc. So, you know, my Skype is here. I got some other folders up there. There's some pictures of my dog and the Tiger King and campus, USD campus. But the reason why I'm showing you this in this moment here is because if I wanted to confirm that I'm actually in the right folder, yeah, the Mac is not better. It doesn't organize any of that for you, Ben, unfortunately. Everyone using a Mac has all your crap in your download folder in one place. So what we're going to go through next is super important. Okay? So if I want to make sure I'm on my desktop, okay, there are several functions that are useful here. So what we just used is the cd space function, or the cd space command, which is the change directory command. Okay, that takes me into a folder. If I wanted to go back out of that folder, I can use cd and then 2 dots following it. All right, so very quickly, I'm in the desktop folder. If I wanted to go back out of the desktop folder, I could do cd space ... That takes me back out. If I want to go back in, cd space desktop brings me back into that folder. Now, to make sure we are actually in the correct folder, what I'm going to do next is I'm going to use the ls command here, which lists all of the files in a particular folder. Okay, now you guys saw I had a cluster of stuff on my desktop. So when I type in ls, what that literally shows me are all of the different files located on my desktop here. That entire mess of stuff you guys saw. For example, here was the picture of my dog. Okay, here are links to some folders on my desktop, home loan stuff. Here are some links to different movies that are showing up on my desktop, different zip files, documents, folders are showing up here in green. So that's all basically the stuff that is listed in my desktop folder on my computer. Those are all the things in my desktop that you could see visually by looking at the actual desktop window, that graphical user interface. Now, before we do anything else, what we're going to need to do is to make sure that our version of Git is aligned, is calibrated with our GitHub account. Okay, so I am going to scroll down over in this useful commands document to the second page. There are 2 pages. And we're going to use these first 2 lines to go ahead and configure our account. So it's really important at this point that you have your GitHub username and your email available, as I mentioned in the email this morning. But I'm going to essentially copy this thing and paste it into Git. And you have to be a little careful depending on your machine, your operating system. The way you paste things in Git may not be the standard Control or Command C, Control Command V. So I'm going to go ahead and copy this, Control C. If I try to use Control V, nothing happens. What I need to do on my machine is I actually have to use Shift. I hold the Shift button down, and then I hit the Insert button, and that actually allows me to paste. But if you can't quite figure that out, you might be able to just Command V it on a Mac. If you're using the terminal window, I think you should be in good shape there. Okay. But I want you to go ahead and just type almost verbatim this command that we're looking at here. Yeah, Joseph, if you have the whole address for the subfolder, you can do cd space and then the whole name for the subfolder, and it'll take you in there directly instead of having to go into each one manually. I'll show you how to do that in just a second. Yeah, no problem. Great question. So what we're going to do is we're going to calibrate our Git so that it is configured with our username. So what I'm going to do now is I'm going to delete this part here. Okay, that shows up in between those little less than and greater than symbols where it says your name. I want you to backspace that and delete it. Okay, so we're going to go here. I'm going to erase the stuff in those triangular brackets. And I'm just going to put in my GitHub username. And mine is my first initial last name, just like my email address. And when you hit enter, nothing should happen. That's actually a good sign. If you get some sort of error, that means you didn't type in that command exactly as how I have it here. Okay, but again, it's git config, 2 dashes, no space, the word global, then a space, user.name, a space, and then your username. Okay, the next thing we have to do is we have to configure our user email using also the git config command here. So let me go ahead. I'm going to copy that back again into the command line interface. I'm going to paste it. I'm going to go back, delete the email in those triangular brackets, I'm going to put in the email address that is tied to my GitHub account, not necessarily my school email, whichever email address you used to set up your GitHub repository or your GitHub account. That is what I want you to use there. And if you hit enter again, if you did it right, nothing should happen. Okay, now if we want to check, hey, what did we just do? Okay, we can use the git config list command here, that third command down. I'm going to paste it in there. And when I run that, what it will do is it will show me the information of which email account and which user Git is currently configured for with respect to GitHub. And we see here some good news, right? The user matches my username and the email matches my email address, okay? So that is the first thing that you need to do today to get Git functioning for you, to match up with your GitHub account, is you have to run those first two lines with your specific username and your specific email address that you use to set up your GitHub account. So that is the first step in our process here. We've configured it. Now what we are going to do is we're going to focus on cloning a GitHub repository. Okay, when I say clone, I literally mean I want to take all the files that are in the repository, I want to move them onto my computer in a folder that contains all the same information. So in order to do that, I'm going to go ahead and go to my GitHub repository, my GitHub account. And I've provided you guys this URL multiple times, so hopefully you're getting used to seeing it here. Okay, but that is my GitHub URL. We're going to go into the class data repository in just a moment. And what our goal for today is really twofold. First thing I want us to do is be able to pull all the files in that class data repository from the cloud onto your machine. So you can edit those files, you can change them, and you can save those changes locally. Okay? The second thing I want us to be able to do is to take any changes we made locally and update them by pushing them back to the cloud repository. Okay? So let's go ahead now. I'm going to click on the class data repo that we are going to clone in a moment. And I want to explain how we are going to do this. Now, before we do the clone manually using the command line interface, using this black window or our console or terminal window, okay, with Git, okay, I'm going to show you how you can do this similarly using the graphical user interface on their website. There's a button here called fork. If you press that, if you're logged into your GitHub account, what that button does is it takes my GitHub folder, the class data folder, and it creates a new branch of it, essentially copies it and clones it, but it puts it in your GitHub account, okay, on yours. Okay, so if you hit that fork button, you should be able to go back into your GitHub account and see that you also have the class data repository showing up. Now, I want to be clear. When you fork it, it will not automatically update changes to those files. It forks the repository in its current form. It will not automatically update any new changes people make, and I will show you how to do that momentarily. Okay, so one way you can get my repository onto your GitHub account is using the fork, but that doesn't get it onto your computer. Okay, that's really what we're going to work on next, is getting the data locally onto your machine here. Now, the other thing we can do is we can use this green code button here. If you click on that, you will notice right away another submenu comes up offering us the option to clone the repository. And there's two ways you can clone it. You can download GitHub's desktop app, which I don't recommend doing. It's new software you got to figure out. Or you could just download it as a zip file and unzip it on your computer using like WinRAR, or whatever unzipping software package you use. And if you need help with unzipping files, let me know, and I'm more than happy to walk you through it. But this is how you can do what we're about to do using the graphical user interface, using this button that I can click, using other links I can click and drag, copy and paste without having to type code manually into that command line window. All right, now I want to make sure you have multiple ways to do the same thing. I want to give you guys some tools and you pick the tool you're most comfortable with. Now, note what is showing up in this repository, right? We got these 8 files in here, which look familiar. Okay, some of them we've used, some of them we haven't yet, but some of that should look familiar, like sales we've seen before. Okay, power plants you might have seen before, cleaning you might have seen before, NHIS we've definitely all seen before together. Okay, but I want you to just note there's a total of 8 files in there. And our goal next is to import all of those files in a single folder into our computer. Okay? And I'm going to do that specifically by moving them into my desktop folder. So recall, I have already switched my folder so that I'm inside my desktop. Okay? If you were not able to do this for whatever reason, it's not a big deal. Okay? If you can't get to your desktop in Git, here's what I need you to do. I need you to be able to use the search bar. I'm assuming everybody knows how to find their search bar on their computer. If you cannot, let me know and I will help you with that. But that is something I think everybody should be able to do at this point. Okay, for example, if I click the start menu here on my computer, that is where I can access my search bar. Right down there in the bottom left, search for programs and files. But you should be able to find that search bar on your computer. Okay, and what you will need to do when we import this repository, this class_data repository, is you will need to search for that name in the search bar. That's the only difference. Okay? So if you could not figure out how do I get into the desktop folder, don't sweat it. A lot of you guys, I'm assuming, are by default starting there. A lot of Macs, for example, default you to that folder when you open up your terminal window. Some don't. But if you can't get there, not a big deal. The alternative thing you will need to do is to be able to use the search bar to search for files locally on your computer. Now, we're in the desktop already. If I wanted to get out of the desktop, we could do cd ... I can move back. If I wanted to go in the desktop deeper, I do cd space and the name of the folder that I want to get into. I'm not sure what you mean by that, Joseph. Your username and email should be on your GitHub account, not in the terminal. It should be the username and email that you use to set up your GitHub account. If you didn't set up the account yet, that needs to be done first. But follow up with me afterwards. I'm happy to walk you through it. Can you tell me what the error says in the chat there? Yeah, just follow up. If you want to just shoot it to me in the chat, I'll look at it and I'll come back to you in a moment here. But I suspect you might have an extra space somewhere where there shouldn't be if you're getting an error for the git config commands. There shouldn't be any space between the 2 dashes and the word global. So you have to almost copy it and paste it verbatim how I've done it. If there's any space, case sensitivity is off, might be an issue, but circle back to me and I will do the same. Now, our goal, intermediate goal, is I want all of these files in the blue box, right? I want all these files here to be imported locally onto my computer. So what I'm going to do next is I'm going to run a new command. Okay, and again, I'm going to go back to this useful commands. We're going to run the git clone command here. Okay, and what git clone does is it essentially is going to copy all the files in that repository, in that class_data repository. And then it's going to create a new folder on my computer with copies of all those files in that folder. Okay, so just like what we had done before, I'm going to go ahead, I'm going to copy that thing, I'm going to get rid of everything inside those triangular brackets. I'm going to get rid of everything inside those triangular brackets. Yeah, I'll follow up with you after, Joseph. We'll figure that out. And I'm going to delete those brackets and I'm going to fill them in with the URL of the repository that I want to clone. So let's go back up there. Okay, here is the repository I want to clone. It is the class data repo. So I'm going to just copy that whole URL. And I want to be clear, we're not importing individual data sets today. We're importing the entire folder, the entire repo. So I'm going to go ahead, copy that URL, and I'm going to come back here, delete that stuff in the triangle brackets, and I'm going to paste that URL. Okay? And what I want to show you is that when I run this, this command line here, when I run that bottom line, the git clone command, okay, what the computer will do is it will literally create a new folder, pull all the files, and store them in it on my desktop. So I'm going to run this, and then I'm going to go ahead and show you that folder. Okay, there's the folder. It made a new folder. And now you can see it's unpacking the information. It's putting stuff into that class data folder. And that's what happened here. And it gave me some, you know, a little bit of technical information over here in the window, but it says it's done. It's unpacked the objects. It's 100% done doing that. If we had a lot of data in there, it might take longer to do this, but we only had 8 files in there. And what I want to do next is make sure we've done the right thing. So right now we're in our desktop folder, but we've pulled the class data folder into desktop. So what I'm going to do next is I'm going to move inside the class data folder. Does anybody remember how we will go inside that folder? Yeah, that's right. We had to use that CD space. That's correct. Okay, so I'm going to do CD space class underscore data. Hit enter. And now, yeah, very good, guys. Now you should see here that the folder that I'm in is different. Okay, it says, oh, now we're inside of the class data master repo folder. Okay, so if I was to run the command ls, if I type ls and run it, what should I expect to see here? What do you guys think? Yeah, I should see all 8 of those files in the repository. So let's make sure that's the case. Okay, I run ls, and then we look carefully at the output, and we see here, oh, there are all 8 of those files that are showing up in the repository that we cloned. So that should be a good verification that we've in fact done the right thing here. We cloned that repository. We have all 8 of those files on our computer. Now, what happens if you couldn't get them on your desktop? Well, if you cloned it, this folder is sitting somewhere on your machine. Okay, this class data folder is somewhere on your machine, which means at this point, you should be able to go to your search bar, search for class underscore data, and you can find that folder, and you should be able to open it and verify that all those files are in there. Okay, now, what is a little trickier, and what I want to spend some time on doing next is, how can I describe the location of a file locally on my computer? Okay, recall that when we wanted to pull data directly from GitHub, hopefully you guys remember how we did that. Like if I wanted the sales data, I went to the sales data, I clicked on it. And then there was one more thing we had to do from here to get the file path for the sales data. Anybody remember what else we had to do here? I couldn't just use this URL. There was one thing I had to do before I could get the URL to import this data. Anyone remember what it was? Yeah, that's right. We had to click on the raw data tab. Okay. So when I clicked on that raw data tab, now it gives me the raw GitHub content. And I could copy that URL. I could go into RStudio and I could say, hey, if I want to scrape that data from the internet source, okay, then we used read.csv. and I put in quotes the file path for that URL, and then boom, we run that. We were able to pull in the data directly from the internet source. Okay, so this was, I think, the easy way to do it, right? We just copied the URL, boom, right in there. I didn't have to worry about this intermediate step of getting the data on my computer. Now, what happens if I have a local data source now? I want to import a local data source. Well, nothing is really different. I'm going to still use the read.csv function. It's still going to use that function. I'm still going to feed it the location of the file. The only difference is now the file's located where? What's the only difference? Yeah, it's like literally located on your machine already now. Okay, so all we're doing here in this RStudio script, the difference between lines 3 and 5, we're going to see in a moment, is one, I'm pulling the data straight from the internet source. The other, I'm pulling the data straight from my computer. And I want to make sure you understand how to do both of those things. Okay, so if I wanted to pull that same file straight from my computer, I can do that now. Okay, we have the repository cloned to our computer. So all the files are now in this folder. So again, you may need to, if you couldn't get to your desktop, you might need to just search after you've cloned the file or you've cloned that class data folder. You might have to search your machine to find the location of that folder, but you should be able to then go into that folder, okay, and then see the contents of that folder, right? There it is. There's all the stuff we expected to see there, all 8 of those files. Now, we imported the sales data a moment ago directly from the internet source. What I want us to be able to do today is import it as if it was just a file on our computer. We should be able to do that as well. Now, what that requires for us to do is to find the file path. I need to find that address. Just like a URL describes the location of data on the internet, there is a file path location that describes where that data is on your computer, and it looks something just like this. This is the file path location on my computer here, the blue box, for where the class data folder is located. Okay. So the file path that is going to describe to the computer where the sales file is located. We can find that pretty easily and copy it, okay, with really 2-button command here. So if you have a PC, here's how you're going to find the file path. You're going to right-click on the sales data, but before you do that, I want you to hold down the Shift button. Okay, so I'm holding Shift, I'm right-clicking the sales data, and now I want you to notice when I go down, there's this option here that says Copy as Path. If you do not hold Shift down when you right-click the sales data, if I do it without holding Shift, that option is not there anymore. So I'm holding Shift down, I'm right-clicking on that file, and it gives me the option to copy as a path. Okay? And I'm going to do that. Now, what if you have a Mac? Very easy. If you have a Mac, the order is a little bit different. So here's what you're going to do. If you have a Mac, you're going to do the equivalent right-click on that file to pull up this menu. And then what you're going to do is you're going to hold down the Option key. Okay, so you got to find the Option key on your keyboard. If you have a PC, don't worry about that. This is just if you have a Mac. Okay, you're going to right-click first, so this right-click menu pops up, and then you're going to hold down the Option key, and you should see when you push the Option key, a new option appears that says something like copy the name of the file as path name. Okay, that is the option that I want you to choose in that situation. So again, if you need to another look at any of that, you should be able to come back here to our useful commands. If you scroll all the way up, okay, I've included instructions for how to find that file path. And this works for folders as well. If you had to find where that class data folder is, same thing. Okay? But either a Mac or a PC, you should be able to figure out what is the address of the file locally on my machine. Okay? So that is what I have done here. Okay, I went in, I'm holding shift, I right click sales, and I copy as path. Okay, now, once I've copied that path, I can go back into RStudio and I can paste the path inside of that read.csv function. Okay, and it might try to put extra quotes in there. You don't need extra quotes. You just need one set of either single or double quotes should work. And now we're able to essentially pull in that data from a local storage, a file that's already on our computer. Okay, however, one small issue here. Does anyone notice anything inconsistent about the structure of those file path locations? It has to do with the direction in which something is pointed. It's a very subtle thing to notice here. But if you look at the green text inside the read.csv functions on line 3 and 5, there's a very subtle issue that may prevent you from pulling in the data locally. Does anyone see what I'm talking about? You look carefully at these lines here. Yeah, very good, Josh. So Josh noted that the forward slashes and the backslashes are switched, right? Down here, it looks like all backslashes in that local path. But up here, the URL has all forward slashes. Now, this may not be an issue for you if you're a Mac user or depending on which version of Windows you are on. But for me, I'm using an older version of Windows. I have to change those backslashes to forward slashes in order for me to pull in that file locally. It's a stupid little cosmetic thing here. You may not have to do that. This is on my computer specifically. I need to. So you should experiment. Maybe you need to, maybe you don't. Okay? But at this point, I should be able to pull in the data either way, either from the internet source or from the source locally. Okay? And you can see here, we've pulled in the data from the source locally. In fact, if we want to view both of them, we can view the internet source, or we can view the local source. And notice whether it's the local source, it's the internet source, it's the same data. We pulled the same file. Okay, the difference was really the mechanics. One was pulling it directly from the internet source, one was pulling it directly from my computer. Now, I want you guys to remember the very first day I explained how you could get data from your computer into R pretty easily. One was you could use the graphical user interface. You could click on the import dataset button here. All right, I could click on that button. Okay. I can find the file on my computer. I can go into my desktop. There's the class data repo. There's the sales data file that we just pulled in. I can hit open. And this is the alternative way of pulling in that file, okay, using the graphical user interface. So a lot of different ways to get the job done if we need to. Okay, what we focused on doing here today was pulling the data by cloning a repository first and then pulling it in locally from our own machine. Okay. Now, what happens if I make changes to data in that folder or to files in that folder? Let's take a look. Suppose I open up this README file here. In fact, here's what I'd like you guys to do. Why don't you open up that README file? Let's right-click it, and you should be able to open it with your notepad. Okay, and you should see there's 2 lines of information in this README file. There's one line up top, which is the name of the repository, and then there's another line I put in there that says "Hello World." Okay, let's go ahead and mess with this file a little bit. Suppose I add another line to this file. Okay, and then I save it. What do you guys think has happened at this point? If I was to go back to GitHub and look on the cloud, has the file on the cloud changed? It has not. Very good. And you might not know whether or not that's the case. So here's what I'm going to do. I'm going to go back to the GitHub repository. Okay, and I'm going to go down and I'm going to look at the README file. And here we can see the contents of the README file, right? The first line had class data. The second line had hello world. And it should be pretty clear that my edits to that document did not show up here, right? If it was edited, you would also see goodbye world showing up there. And it's not. All we've done is we've edited the file locally, and I've saved the changes locally. Okay, now Git. Git itself is what is called a type of version control software. What Git is really powerful for and extremely useful for is if you are doing some sort of collaborative work, or maybe someone takes some data or a file, they make some changes to it. Okay? And then now they hand it off to you and you have to make changes. What Git will do is it will track all the changes that are made between versions of the file. So it's literally controlling and tracking how different versions of that file change over time. Okay? That is what is happening here. So what we still need to do is we need to essentially add these changes to the repository. We need to commit to those changes, and then we need to push them back to the cloud so that the original file in the cloud matches up with the new changes that we've made locally on our computer. Okay, so that's what we're going to do next. So let's go ahead, and I've changed something in the class data repository. So I'm going to now go ahead and I'm going to use another important command line function within Git. In fact, if you scroll down, do you guys notice a little something different about all the commands in Git versus the generic CLI commands? There's like a big difference that should tell you it's definitely a Git command. What do you guys notice about all of that first syntax column here, if we're talking specifically about Git commands? Yeah, they all start with the word Git. Okay, they all start with the word Git. So if you're wondering why isn't this working and you're not using Git at the front of that command, that's probably why. Okay, so we've cloned the repository using git clone. What we need to do next is we're going to check the status of our changes. And so I'm going to close this file here. We're going to check the status of our changes. So I'm going to use the git status command. Okay, and that is the only thing I'm going to run here. Now note we're inside the repository folder. If you do this, but you're not inside the repo, you're going to get an error saying, hey, this is not a GitHub repository. Like if I was in the desktop and I try to do git status, I would get that error. Okay, but if I run git status here, I want you to look very carefully at what that tells me. Okay, Git is saying, hey, you changed something over here. You changed the readme.markdown file. Okay, so it recognizes, hey, something is different compared to the version that is stored on the cloud. So this is where version control comes in. Now, if I want to add those changes to be committed back to the cloud, okay, here's how we're going to do that. We are going to use the git add command. Okay. And I'm going to use a very specific one. I'm going to use git add -a, which adds all of the files that we had changed. If you want to go piecemeal file by file, there are other ways to do that. There are other ways to do that. Okay, but I'm going to just do git add -A, case sensitivity matters here. I'm going to add all of those files we've changed, and we've only changed one of them. We've just changed that, that README file here. So let's do this. Git add -A. And when I run that, now you'll notice nothing happens. Okay, and that's actually a good sign. Okay, what we're going to do next is we're going to check the status again. Okay, the first time we checked the status, it said, oh, readme.md was there in red. It was modified, and we didn't add the changes. But now we've added the changes. So if I check the status again, it's not going to tell me that these changes are new. It's going to say, hey, we've tracked those changes down. Okay, so just like in the R console, if you hit the up button, okay, while your cursor is down there on that command line, you can move back and forth between the past things that you've entered on that command line. So I'm just going to go back to Git status, and I'm going to run the status check again to make sure there's not any other files that were changed that we did not account for. So I run Git status again, and now I can see we are in better shape. Here, yeah, the README was modified, but now it's showing up in green. Our branch is up to date with the origin, meaning we are ready now to push that data to commit it back to the cloud. Okay, we had some change, we checked the status, we identified the change, we added the change to be committed, and we verified that again with the status check. Okay, what we're going to do next is we are going to commit that change. So in order to commit that change, we're going to use the git commit command. And there's an optional -M here where you can put a little message to yourself. I recommend doing this so you're keeping track of what it is that you've changed or what other files you've added, just for yourself and anyone else you are sharing that repository with. So let's go ahead and we're going to run git commit. And it says message goes here. So I'm just going to put a message to myself. We updated the README file and added goodbye world. That's essentially just a little note to myself describing what it is that we've done here. Okay, so I'm going to run that. Just hit enter. You don't have to hit control or command enter to run it in Git, by the way. Just regular enter will run that for you. Oh, sorry about that. I just need single quotes up here, not double quotes. Just single quotes for that message instead of double quotes. And now it says, okay, we are good. Okay, one file had changed. There were some insertions. There was a deletion. Okay, and we've updated the README file. We've added goodbye world. Okay, now we are ready to push the changes that we just committed. So the very last step to get those changes back into my GitHub repository, I'm going to use this very bottom function here, git push, and then there's a lowercase u preceded by a dash, and then the words origin and master separated by the spaces. We're pushing everything we've added to that folder and the old files from the origin, from its origin on my computer locally, back to the master repository globally. Okay, so before I run this line here, I do want you to convince yourself that still if we refresh the page, if I go back out and I go back into the README file, that I don't see our changes showing up. Still, I do not see any goodbye world down here. It's not there. We still have not pushed those committed changes back to the repository. So checking the status provides us one kind of layer of security, so I don't accidentally change something without realizing what I've changed. Adding it gives me another layer of security. Checking the status again, another layer of security. Committing, another layer of security. And now I'm ready to push. Okay, so let's go ahead. Let me back out of the README file content here. We're back in the repository. And what I want us to do now is go ahead and run this last command. We're going to push from the origin back to the master. Okay, and when you run this, you may be prompted for your GitHub username and password. Put those in. Okay, the computer will not let you will not let anybody mess with your files. So if you want to push back to your account, you have to have the credentials for your account. Some random person that accesses your GitHub repository will not be able to mess with your files unless they have your username and password. So when I run this, okay, it starts telling us some things about compressing the file. I actually ran this already in the last session, so you didn't see it here, but it did prompt me for my username and password. I would put those in. But now, if I was to go back and check the status, right? Or better yet, let's look at the repository itself. Okay, if I click on that README file now, okay, in fact, let me just refresh this page here so you guys can see it. If you look at this row, okay, this is the README file, but this is from the changes that I made 2 hours ago. So I want to be clear, our updates didn't show up here yet. This is when I added Hello World. But let me refresh this page. Let's go ahead. I just want you guys to refresh that page. And now when I refresh the page, you will notice that my changes have shown up. Instead of Hello World, it's Goodbye World. And this was the change that I had made 4 minutes ago. So now if I click on that README file, okay, we should be able to see here that our changes showed up. We added that Goodbye World, and it is definitely showing up now. So we've done a few things here. We scraped some data by pulling from a GitHub repository all the files in that folder locally. Okay, we then thought about, well, how can I find the file path, the locations locally on my machine if I wanted to pull that data into RStudio to analyze it? And we were able to identify that file path for pulling data in locally. Then we looked at, well, if I wanted to change some of those file contents, I wanted to change some data, maybe I'm doing cleaning or I want to update a document, we looked at how to check the status of the repository, how to add the changes, how to commit the changes, and last but not least, how to push those changes. So here is a summary of the entire process. First thing we did after configuring our account is we cloned the repository. Okay, once we cloned it, okay, we made some changes. Okay, then we checked status of those changes. And once we did that, we added the changes. Then we committed the changes. Okay, and then last but not least, item 6 here, we pushed the changes back to the cloud repository. Okay, so that's essentially the process that we had just looked at there. That is the process that we had just looked at. So this is the expectation for this course. You should be able to pull data from a GitHub repository onto your machine, get that into R, maybe edit it, clean it, and then push the changes back so that on the cloud repo, the changes that you've made are updated. So the general theme of today is scraping data or scraping information from an internet source. And that is what we are now able to do, specifically scraping data from GitHub. That being said, I also want to show you how you can scrape a web page, okay, how you could scrape a URL for all of the HTML code that is used to build the web page. Okay. So just out of curiosity, if you've taken Econ 385 with Professor Sanchez, just drop me like a yes in the chat or a hello world or something. I'm trying to get an idea of how many folks in this class have taken the 385 course with Professor Sanchez. If you've taken it, just drop me a little note in the chat there. I'm just kind of curious how many folks have at this point. If you haven't, no sweat, doesn't really matter at all. But in her course, her class is focused a little bit more on things revolving around like text analytics, scraping Twitter to analyze really string data or character data, which is specifically text. It's not numerical data. And what I'm going to show you in a moment is useful in that type of analysis. If you're wondering, how can I, for example, get all the information on someone's website into a variable? Okay, like all of the information on the website into a single variable. We can do this. Okay, so I'm going to show you how to scrape the HTML from a website in a way that captures all of the stuff you see showing up on the website. Okay, so let me go ahead here. I'm not trying to plug my website, but I'm going to just use my website anyway. You go to my web page. You know, there's a lot you can see on the web page. There are pictures right here and here. You know, there's a banner, there's a title, there's some other text that you can see showing up. There's my office location, contact information. There's links to files. There are different tabs you can push. Okay, what I'm going to show you guys is how you can use one line in R to pull in all the HTML from this web page. Now, if you were to hit the button, I think it's F12 or F11, you can actually pull up the HTML corresponding to a web page. It is F12. Pulls up all the web page scripts. So you can look and actually see the structure of the web page here if you wanted to. What we're going to do here is we are going to pull all of the coding of the web page into a single variable in RStudio that will essentially explain to us all of the source code, and it'll contain all of this information that is showing up here in text. That has to be there in the HTML code that is used to generate the web page. All right. So I'm not trying to just, plug my website for no reason here. I picked this one because I think there's information we can see here, and I want to make sure we can scrape that information into RStudio. So at this point, I'm going to show you how to scrape the data from a web page. So let's just call this variable scrape. And I'm going to store in it the output using the read.lines function. Okay, this function we haven't used before, okay, but I bet you can guess what it does. It reads the lines of the HTML that are used to build a web page. So all I'm going to do here is I'm going to get that HTML URL. So I'm going to take the URL from my website. I'm going to copy it. And I am going to paste it right in there. Okay, so this is the website's file path. That's what we needed. I'm using the read lines function on it, and I'm storing all the output in a variable I'm calling scrape. So let's run that. And now I can see here, hey, I got a variable scrape. And if you want to check the class of it, okay, you'll notice it's not a numeric variable. In fact, we can see that up there in the console window, right? It is specifically a character variable here. Right, it is a character variable. Okay, which essentially means it's a variable that contains a lot of text. In fact, if we were to view the variable that we just created, let's do that. Let's go ahead and view the scrape. Okay, and it looks like it took all of the HTML and it stored it in one column that R automatically labels V1. So there it is. And if you scroll down here, you should be able to see some elements of the web page popping up. Right, there's the title text. Okay, so if I looked at scrape, and I looked at the fifth element of scrape, there's the title from the HTML from the web page. Okay, if I wanted other information, I could consider other elements of the scrape. Right, 6, 7. Okay, there's a lot of information, right? There it is, economics, UCR, blah, 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 blah. So there's other content in there that we're able to capture that you may not even see displayed on the web page. But all the information on that web page and more information, including how the page is built, is stored in this very, very long vector here. In fact, if we check the length of the scrape, spelled length wrong, there we go. It's actually got 186 lines of stuff that it is storing from that web page. Okay? So today, the focus was shifting gears a little bit in terms of thinking about how to scrape data from other sources. We pulled data from a GitHub repo by cloning it locally. We talked about how you could fork it, just copy it from one repository to another. We discussed how you could import the data locally by identifying the file path location on your machine. So we can pull data in from internet sources. We can pull data in locally. We can scrape web pages for text data if we wanted to analyze that. So all of this should be fairly feasible for you guys at this point. If you got stuck on any of those steps using Git, using the command line interface, please do not hesitate to reach out to me, set up some time, and I can go through that with you one-on-one to make sure you are in a good spot.